So we were talking about this matrix. We say that we have these intensities corresponding to these x's, but then we want to have a matrix that looks like this. So for each row that we have here, which corresponds to intensity, for example, this is row 1, so it's intensity I1, we want each of the pixels that are laying along our y-axis, at that x, we want them to have the same value. And then for the second row, so this was the first row. For the second row, let's say the value of the intensity is I2, and then we want for each of the pixels on, so this is x1, this is x2. It has the same value of I2, and the same here. So we need to define for loops. Now, how many for loops do we have? So we need one for loop for constructing the pixels so that we get a height for the strip of our brightness or darkness. So for any j in this range, just assign these values to those columns of the matrix, right? Because these are corresponding to different columns. Another for loop is for our x, because let's say this is our screen, and then we want to start from a point here. And let's say the width of our screen, we call that W, the width of the screen. And let's say that is 0.1 meter, so it's 10 centimeter. And that basically is like if we have this slits, and then this is the observation point, we are gonna get this pattern, and this pattern is laid out along 10 centimeter. Now let's say we want to have 1000 x's. So we have to define another for loop here for x's. So I will say for I in range, let's say steps. Let's set that to 1000. If I want to include steps, I have to add it by 1. So let's say for I in range of steps plus 1, then set x equal to, and let's say this is the beginning of the range, this is the end of the range, and here at the middle, this is 0x. So this is the x-axis now. This is the y-axis. This is our screen. So we start from this, and then every time we add it by the separation distance between each x. Now the separation distance is just ws over steps, right? Depending on our number of divisions. These are the steps across the screen along the x-axis. So we have to multiply I by ws over steps. Let's see if it's working. So for the first time when I is 0, I'll just get x equals negative ws over 2. So I will start from here. The second time that I is 1, then I'll get x equals negative ws over 2 plus I times that separation distance, which is this distance. So I'll get to this point, and so on. And then after 1000 steps, I'll get to here. So this is a for loop. And then each time that we define this x, then we want to compute I over I naught, which is our equation. And the equation, let me just write it here. So I over I naught was sine of sigma over 2 over sigma half, and this was the squared. And this goes here. This same function goes here. So we have, let me just write it one more time. So for I in range steps plus 1, we get x. So we just go with definition of x. And then for each x, find this intensity, which is sine of sigma half over sigma half squared, and then let's call that g. And then every time that you found the intensity for each x, which is basically where we have here, then we want to construct these columns, and so we need another for loop. So then for, and this indentation should be all aligned, for j in range. Now the range is depending on the height of the pixels. So the height of the pixels, then just, so if I define an empty matrix, which I just call it data, then data of j and I equals to this j that we fixed here. And so note that j is sitting in a set of the row, and I is sitting in a set of column. So remember, I was associated with the x's. J is associated with the height of the pixels, which are along the y-axis. But because in matrix, because the values of pixels are along the rows in the matrix and the values of x points are along the columns of the matrix, then these become switched here. If we have this matrix, we have to define an empty two-dimensional array. So data is gonna be empty, and then here we have the dimension of the matrix, and then the type would be float. So now here and here. So this is the dimension of the rows, which is determined by the number of pixels. This is the dimension of the columns, which is determined by the number of steps. Because the steps are n, so these are like 1000 x's. And this is the dimension of the matrix. So let's get started. Okay, let's get started. So I'm going to copy paste the first program that we have here and then start to adjusting it. So from PyLab, this time we need imshow. So I will add that, and then I have this information already. I don't need the line space, and I need to define my for loop. So for I in range of steps plus 1. So that means we need to define steps here. Let's go with 1000. And so for each number of x, we wanted to find the position of that x. So I will go with ws over 2 plus ws times I over steps. And that means we need to define ws. Let's set that to 10 centimeter. And then at each x, then we want to find the value of intensity for it. And I'm just gonna call that G for now. So G is equal to, and let's say we are plotting this for a single slit. So this is the value I need. I don't need this value. And now for each x, I wanted to define another loop for J, and for J in range of height of the pixels. So if I call that, set that equal to 250, then colon, now I wanted to pour the value of G, which is the intensity, into an empty array. So I have to define an array that goes with J and I, which means here I need to define an empty array. So data equals empty. So the dimension of the rows is determined by the number of pixels, and the dimension of the columns is determined by the number of steps. And then we have float. And so now if I come back to here, and this should be I, this is equal to the J that I have up in this line. Now I don't need the plotting statements. Instead I'll go with imshow, and I wanted to provide a density plot of this matrix of data. And so this is for a single slit, and we have included S here, which at this point we don't need S, but we do need FA, and here we have F of A. So let's plot this to see what we are gonna get. So it says name empty is not defined, so we need to import empty from numpy. Let's go one more time. Another error, name HS is not defined. Right, so I have to remove this line from here and put it before array. Steps, the same for steps, because I have it inside of this line. So first I have to define steps, and then I have to go with the line for empty array. And I get something like this. Now I want it to not be in color, because if it be in black and white, for fringe pattern, it would be easier to compare, because next we want to plot the fringe pattern for double slit. So let me add the this is statement, which is gray. And I also have to import it from PyLab. So then I'll get something like this. So this is my central maximum with the highest brightness. And now if I copy paste this code and then adjust it for double slit, let's see what I'm gonna get. So here I'm just copy pasting this. So if I paste it here, now what are the lines I need? This time I need S and also I need f of a. Now instead of this line, I have to use what I have here. Because remember, for double slit, we have this cosine squared as well. And I'm gonna paste it here. Let me call, instead of J, I'm gonna go with something that I haven't used before. I'll go with E. And then now I don't need this line. So let's go with that. So now we get this fringe pattern for a double slit. As you can see, if I compare this pattern to what I have here, you will see that the central maximum along the x-axis, it has a larger x compared to the central maximum for a double slit, right? And let me make this a little more accurate. Right now, my x is in the scale of steps. I want it to be in the scale of x, and for that we need to use the extend command. So extend equal bracket. Inside the bracket, I will have negative ws half, ws half. So these are just the scale for the x-axis, and then for the y-axis, I want it to start from 0 to ws over 6. Now if I plot this one more time, so these are now the width of the screen, and the same thing here. I'll just copy paste it. Now if you look at here, at x equals 0, the width of this maximum is much less compared to this one. This is about from negative 0.02 to positive 0.02, whereas this one is much less. It's even less than half of 0.01, the width of the central maximum. But as you can see, it looks that the brightness, let me see if I can zoom this a little bit. When I'm looking at it, it feels to me that here the white color is more pure compared to here. In this region, the white color has some grayish color in it as well. And it will be hard to quantify that the intensity here is 1/4 of the intensity in the central maximum of a double slit.
However, this looks to me
a little brighter. But it's definitely hard to quantify it with just looking at it with bare eyes.